Now let's take a look at our first problem here. We're given the following data, time in years, and then profit in thousands of dollars. So that means year one we had $8,000 profit, year two at $10,000, and so forth. First thing we want to do is draw a scatter diagram. So let's go over to our calculator, and we're going to input our numbers. So I'll do stat, do enter on edit, and our x values we're going to put into L1, so 1 through 5. So 1 enter, 2 enter, 3 enter, 4 enter, 5 enter. Now I'll press my right arrow, go over to the L2, which is where we're going to put our y values, which is the profit. So we got 8, 10, 15, and then 21, and 33. Let me double check my numbers. 8, 10, 15, 21, 33. Okay. Now we'll exit out, so do a second mode. And we're going to go into y equals just to make sure. You shouldn't have anything on y1. Unless you're sharing your calculator with somebody with algebra, you probably don't. And we'll do second y equals. Now we want to do enter on 1. And we want to select on. So my flashing cursor is on the on, so I'll press enter on the on. I'll down arrow to the type, and we want the first type. If it isn't already selected, just press enter on it. Now down arrow. For X list, we want that to be L1. If it's not L1, do a second 1, enter. And for Y list, we want that to be L2. If it doesn't say L2, do a second 2, and then press enter. Now, remember, we put our X values in L1 and our Y values in L2. So now I'll do a zoom, and I want to choose number 9, zoom stat. There we go. And that's our scatter plot. Excuse me. So that's part A. Now step part B, find a correlation coefficient. Your diagnostics has to be on. If you got one of the newer T84s, if you press mode and go down, you can turn the stat diagnostics on right here. See where it says off and on? You just down arrow to that row, and then you put right arrow over, put your flashing cursor on the on, and press the enter button one time. And then second mode, exit out whenever you're done with that. Now this way works on every calculator, T83, T84. If you do second 0, go into your catalog, and you down arrow to diagnostics on. It's quite a ways down. Or you can quickly go down to the D's by doing alpha x and negative 1 twice. So alpha x and negative 1. And let's go down to diagnostics on. There it is. Once the little markers next to it, you press enter twice, and I'll set your diagnostics on. It's probably set from class, but if it isn't, that's what you have to do. Then we'll press stat, right arrow to calc, and we're going to down arrow to linear regression. Now you shouldn't have to do that diagnostics on again. It'll stay that way until your calculator goes dead, batteries or whatever. So I choose linear regression and then press enter. And the correlation coefficient is our R. So rounding 4 decimal places, we got 0.9583. And that'd be your answer for that. Now let me come over here and write some of this down. Okay, so B, we just said R is equal to 0.9583. Now for C, it says, does a linear relation exist? Provide proof. Well, we need to find the absolute value of R, which the absolute value of 0.9583 is just 0.9583, because it's already positive. And we need to find our critical value from our table. And I have this in a PowerPoint, so let me just bring up my my PowerPoint. You just look it up in your book. And of course key is if I can remember which one it's in. I think it's that one. These are our steps for testing for a linear relation. You determine the absolute value of the correlation coefficient. Find a critical value in table 2 from appendix A. Now that may change for different editions. It may become table 3 or whatever, but you're looking for the one for critical values for correlation coefficient. Well, n is how many pairs do we have, and for this particular problem here we have 5 pairs of numbers, so n is 5. So come up here, look up n is equal to 5, and we got 0.878. So 0.878. Now if the absolute value of r is greater than your critical value, then that says there's a linear relation. And that's just off the PowerPoint here. If absolute value of r is greater than critical value, linear relation exists. Now if it's less than or equal to, then no linear relation exists. Okay. Now D says find the least squares regression line. Well, this is y hat that we're trying to find, least squares regression line. And if we go back to our calculator, it's actually right here. You see the a and b, 6.1 and negative 0.9. You plug that into the a and b up here. So we get y hat is equal to ax. A was 6.1. So we got 6.1x. And then plus b, which is negative 0.9. And that's our least squares regression line. Now E says draw the scatter diagram again with the least squares regression line graphed on it. Okay, so we got this graph right here. If I come here and if I press y equals, I'm on y1 and I'll type in 6.1x minus 0.9 and then press graph. Now my scatter diagram is still there. Now it puts the line on there so we can see the two together. So that'd be the answer to part E. Now F says predict a profit 8 years. Now profit is our y values. So get something going here. There's something spilled on my little tablet. Okay. Okay, so F, predict the profit 8 years. So when x is equal to 8, they're wondering what the profit is. And profit, again, is our y. Well, we use our least squares regression line. We got y hat is equal to 6.1x minus 0.9. So we're going to plug in the 8 for the x. And let me plug that in my calculator and see what I get. .1 times 8, we get 47.9. Let me see. G. Compute the sum of the squared residuals. Okay. So G. We got our x values, which I think were 1, 2, 3, 4, 5. We got our y values, which were 8, 10, 15, 21, and 33. And y hat, which we got the formula for that. That's 6.1x minus 0.9. So what we're going to do is we're going to take each one of our x values here and plug it in for the x here. So we've got 6.1 times 1 minus 0.9. We got 6.1 times 2 minus 0.9. 6.1 times 3 minus 0.9. 6.1 times 4 minus 0.9. And 6.1 times 5 minus 0.9. Let's get a new tablet here someday. Getting so many little places in there, it's hard to write. 6.1 times 1 minus 0.9. 5.2. And 6.1 times 2. 11.3. And times 3. 17.4. And times 4. 23.5. Excuse me. Minus 5, we get 29.6. Okay, then we need a new column. Y minus y hat. These are actually our residuals right here. So we're going to take y, which is 8, minus 5.2. We'll take y, which is 10, minus 11.3. We'll take 15 minus 17.4. 21 minus 23.5. And 33 minus 29.6. So 8 minus 5.2. I get 2.8. 10 minus 11.3. Negative 1.3. 15 minus 17.4. Negative 2.4. 21 minus 23.5. Negative 2.5. 33 minus 29.6. And 3.4. Well, then we want to square those. So I got 2.8 squared. Negative 1.3 squared. Negative 2.4 squared. Negative 2.5 squared. And 3.4 squared. Remember, when you square anything, it becomes positive. So that's 7.84. 1.69. 5.76. 6.25. And 11.56. Okay, sum of the squared residuals. That's the sum of y minus y hat squared. So we got 7.84 plus 1.69 plus 5.76 plus 6.25 plus 11.56. And we get 33.1. And that'd be the sum of the squared residuals. Okay, now if you're decent with the calculator, you can actually do this on the calculator. If you're kind of weak on technology, just do it by hand, like I just showed you. It's just not that easy on the calculator. Now do second mode to exit out. To do it on the calculator, you must have already done your linear regression. So that's your first step. Well, then we'll go back into our, and look what our A is. A is this, B is this. Well, if I press Stat, go into Edit, and right arrow until I'm over in L3, and then I'll press up arrow to highlight L3. We had, remember our columns over in the other sheet. We had our X column, our Y column, and we have our Y hat column. So I'm going to put my Y hat right here. Now L3 is highlighted, so I'm going to press my let's see, variables. Choose 5 for statistics. I want to right arrow over to the equation, and I want to down arrow to A. And press enter. Now remember, the form of our least squares regression, the y-hat, was ax plus b. Now x is our L1, so I'll do times L1, so I do second 1. And then plus, and we won't go back into our variables, vars. Choose 5 for statistics, right arrow over to equation, and down arrow to b, and press enter. And then you see we have ax plus b. And if you press enter on that, then that'll give us our y-hat. Now I'm going to come over to right arrow over to L4, and I'm going to up arrow and highlight L4, and I'm going to go ahead and put all this in at once. I'm going to do y minus y-hat squared. So L4 has got to be highlighted. We'll press beginning parentheses. Y is in L2, so I'll do second 2 minus y-hat, which is in L3, so do second 3, closing parentheses, and then squared, and press enter. And you see I got 7.84, 1.69, 5.76, so it same numbers we came up with right here. Okay, now remember that's an L4, so we'll go ahead and exit out, do a second mode. And let me clear that. And if we press second stat and right arrow over to math, number 5 is a sum function. So I'm going to choose sum. And I'll put in second 4 for L4, closing parentheses if you want, and then press enter. And we get the same thing without doing any writing at all. We just do it on the calculator. But like I said, if you're not very good at technology, that's kind of intense on the calculator. If you're good at technology, I'd probably click right away. So if you're not understanding that, don't come to me and ask how you do it on the calculator, because that means you're not technology oriented. Do it by hand. Okay, let's see. Find the residual at year 6, assuming the profit is 50. Well, let's remember what our formula was. I've forgotten it myself. Was it 6.1x minus 0.9? I got it from right here. Now, when they're telling us, assuming the profit is 50, they're telling us that y is equal to 50. That's the actual data point. And we're going to use this to model it to see what our predicted value is. So, find a residual at year 6. So, we're going to plug in 6 for the x and see what the predicted value is. So, we got 6.1 times 6 minus 0.9. I get 35.7. And I don't know why I don't got both lights on in my room so I can actually see. There it goes. Okay. Now residual is y minus y-hat. So we're going to take 50, this value right here, minus the 35.7. It gives us 14.3. So that'd be our residual. Remember, residuals like your error. Okay. I. Draw the coefficient determination. Well. Did I say draw it? Find the coefficient determination. So that's I. So I'm going to go, and I should have wrote it down before, but if we just press stat, right arrow to calc, and go through linear regression again, number 4, and press enter. Our coefficient determination, capital R squared, is equal to little r squared here, you see. So it's 0.9183. Like that. Now the last thing they're asking here is, where's it at? Okay, draw the residual plot. Okay, so we're going to go back to our calculator. Now remember, let me go to stat and go into edit, just to refresh your memory. The x values, if I left arrow over, the x values are in L1. Okay, so let's exit out, do a second mode. Now I'm going to press Y equals. I want to go and clear off what we put on Y1. So I'll press clear. I'll do second, Y equals. Press enter on plot 1. Now it should already still be on here, but if it isn't, press enter on the on. We want the first one chose. It should already be chose, but if it isn't, down arrow to it, have your flashing cursor on it and press enter. Now our X list is our actual X values, and that's okay, that's in L1. Now when we get to the Y list, I down arrow to the Y list. If we go into second stat, you see the residual ID down there? It's number 7. I've been told on some calculators the residual ID is further down, but you may have to down arrow to see it. And then we'll press enter on it, and you see residual ID there. Now we press zoom, and we want to choose number 9, zoom stat. So you can just press number 9, it'll down arrow and do the enter for you. But I want to show it. Okay, so here's zoom stat. And then press enter on that. And that's our residual plot. And that's actually the last thing that they want in problem number 1.